Okay, we're going to look at some circle angles and arcs today. So we're going to be starting with some vocabulary on page 253, making sure that you know what these terms are. The central angle of a circle is an angle that is in the middle of a circle. So if you see this angle, I'm going to highlight in purple, angle AOB. Angle AOB is a central angle of this circle. So it's just the angle in the middle of the circle. The middle variable in that angle is the point that is in the center of the circle. So AOB is a central angle. A minor arc is any arc in a circle that is less than 90 degrees. Now, the way we mark an arc, less than 180 degrees. So the way we mark an arc in a circle is we write the starting letter and the ending letter of an arc, and then we put a little symbol that looks kind of like an arc over the top of it. So you see I have in red arc AB. This is actually a minor arc. In fact, I know the value of AB. The arc AB is equal to 70 degrees because it is a very important thing about central angles that the central angle always equals the arc. So the value of the central angle will always equal the value of the arc. So that is going to be true for any circle. So since this angle is 70 degrees, the value of this arc is also 70 degrees. Now, once again, we talked before when we did arcs that you could measure arcs in degrees or you could measure the length of the arc. We're not saying this arc is 70 inches long or 70 centimeters long. We're saying you turn through 70 degrees of the circle to go across that arc AB. Okay, now let's go ahead and look at some other arcs. A major arc is an arc that is over 180 degrees. So this circle, as I've drawn it right now, does not have a major arc, but we can fix that very easily by just sliding this point here. And you can see at this point, this arc here that is in purple is a major arc because it is over half the circle. So this arc that I'm going to kind of go over in purple here, it is going to be a major arc. So, and the way I talk about a major arc is this major arc I would call arc ADC. You can always tell a major arc from a minor arc because a major arc, they have to include 3 letters. Here's why. If I just said arc AC for this circle, it's going to look for the shortest route from A to C. So the shortest route from A to C for this arc AC would be to go A around the short way this way, which would be about 160, 60 some, maybe 170 degrees, a little bit under half a circle. If I went the other way, arc ADC, it's going to be a little bit more, a little bit over 180 degrees. So it is the major arc of that circle. So major arcs are over half a circle. Minor arcs are any arc under half of a circle. And major arc always uses 3 letters. Minor arc always uses 2 letters. A semicircle is exactly half of a circle. So we'll clean up some of this stuff we have here. And I'll show you a semicircle very quickly. A semicircle, I can just take, and it will be exactly 180 degrees. So if I have a 180 degree, I could say, hey, this arc here, let's go ahead and label it arc ADC. Oops. DC is 180 degrees. That means it is a semicircle. It is also true that arc ABC is also 180 degrees. Basically, if you have a semicircle on one side of the circle, you're going to have another semicircle on the other side of the circle. Semicircles, you are going to need to use 3 letters because, as you can tell, if you just say AC, they don't technically know which one you're talking about, whether you're talking about the one going around the back side of the circle that we have in blue or the one going around the front side that we have in purple. They're both 180 degrees, but technically they're 2 different arcs because they're 2 different pieces of the circle. We've already talked about the measure of an arc. When you talk about the measure of an arc, it is the number of degrees. So if you want to write something beside measure of a minor arc, you can say that's always less than 180. Measure of a major arc is always more than 180. Adjacent arcs are arcs that are next to each other. So I'll clear off these marks again. And it would be true to say that arc AB and arc BC are adjacent. So AB and BC are adjacent. So these are adjacent arcs because they are arcs that are next to each other. You can see as I mark them on the circle that one arc AB clearly touches arc AC. Now, the useful thing about adjacent arcs is you can add them together. So it is perfectly fair to say that if I had the measure of arc AB and I added the measure of arc BC, it would be equal to the measure of the entire arc ABC. Now, this is just kind of common sense. The same thing happened when you had a line segment. If you had 2 small segments next to each other and you added them together, you got the whole segment. Well, same thing here. If I know that this arc here is 70 degrees, and if I know that this entire yellow arc, that entire semicircle, is 180 degrees, I can figure out the measure of arc BC by just saying, okay, arc BC would have to be 180 minus 70, because I know the top piece is 70, so this piece here from B to C would end up being 110 degrees. So if you have the 2 small pieces, you can add them together to get the big piece. If you have the big piece and one of the small pieces, you can subtract. Same things you did with segments will apply to arcs. We have already talked about congruent circles. The reason they're bringing congruent circles back up is if you have 2 circles that are congruent, their arcs would be congruent. I'll show you a quick picture of this. So if I look here, I have 2 different ways to have congruent arcs. One way I can have congruent arcs is in this circle on the left. You notice that this arc here and this arc here, the central angles are equal. So if the central angles are both equal, both of these arcs are 70 degrees because they're in the same circle. So arcs in the same circle that have the same central angle are congruent arcs. They have the same measure in degrees, and if we did arc length, they would have the same arc length. It's also true that if the circle itself is congruent, meaning the circle had the same radius, so let's say the radius of both of these circles was 3. If this circle has a radius of 3 and this circle has a radius of 3, a 70-degree angle arc in this circle would match up with a 70-degree arc in this circle. So that would be true. Now, clearly, if your circles are no longer congruent, if I did for example, if I were to increase the radius of this second circle and make it bigger, this is still a 70-degree arc, but you can tell that this is 70-degree arc is clearly not congruent to the purple 70-degree arc because this circle no longer has a radius of 3. It has a larger radius, looks more like a 6. So for the arcs to be congruent in different circles, the circles themselves have to be congruent, meaning they have the same radius. It is true that these 2 arcs are similar. The blue arc here, this larger 70-degree arc, is similar to this 70-degree arc I have in purple on the smaller circle because they are proportional to each other. And actually, the length of the arc would be twice as long since the radius of the circle is twice as big. But the measure is the same, but they are not congruent because you can tell their lengths have changed. So similar arcs mean the circles aren't congruent even though the arc measures are the same. That gives you a pretty good idea of what is true about these things. I'm going to help you out with one or two problems here on page 255 to kind of give you a jump start on your work. So as we're looking at, this is a lot like number 10 on page 255. And what I have here is I have a circle, and we'll call it circle K like they did on number 10. So K is the point in the middle of the circle, and we'll go ahead and label some of these points A, B, C, D, and E. So it matches up to number 10. And it tells us that this is 55 degrees, and it wants to know the measure of arc DE. Well, one thing you need to know is that since the central angle AKE, this angle here, AKE, is 55 degrees, it is also true that this arc over here is 55 degrees. Another thing you need to notice is that you have a diameter of this circle. A to D is a diameter of the circle. So this arc that goes all the way around here is a semicircle. So it's true that AED is equal to AED, sorry, that looks a little bit like a B. AED is equal to 180 degrees because it is a semicircle. Well, at this point, I can find DE pretty easily because if this whole thing is 180, I can do 180 minus 55, and then that would leave you with the value of DE. If they wanted to know some things about the top, you could potentially find out a little bit of information about the top, but there's not as much that you know there because all you know on top is this is 30 degrees. So with the information they've given you, there's really, you could continue going because you know that not only was AD a diameter, but CE is another diameter. So I'm going to mark it in red. So if that is a diameter of the circle, just showing you how you could extend this further, I would know that BA would have to be, I could solve it because I could say the whole thing from C to E was 180. So I could do 180 minus my 30 degrees for BC, and then minus my 55 for AE would give me just this value here of this angle or the value of that arc. So that just shows, and then once you had that piece, you could use the piece for AB and BC to find CD. So this shows you how you could start with a rather small bit of information about a circle and go a long way. One last thing we'll look at is kind of like number 11. On number 11, they called that circle E. So E is the point in the middle, and we'll label the points on the outside kind of what they had, A, B, C, and D. And on number 11, they're asking you to find the measure of AB. And you're like, well, they told me AB, that's 5x. Well, it is 5x degrees, but they would like to know the value of x. So it'd be nice to look for a semicircle, but you can kind of see you do not have a semicircle to use on this one. So the only thing I can use on this one is I can basically add up all the arc segments. So I can say 5x here plus my 40 degrees that was over here plus my additional 70 degrees, which was over there, and then add on the amount down there, which they had as 75 plus 2x. So I could add all of that together. I'm running out of room to work. I'll see if it lets me right over here. So I'm going to add my 5x, 40, 70, and then 75 plus 2x. Well, putting like terms together, 5x plus 2x is 7x. Add all those angle amounts, and I get 185. And then since I added everything all the way around the whole circle is 360 degrees. So if all else fails, if you can't find any semicircles or arcs that you know, you can always go all the way and say, hey, the whole circle adds to 360, so 7x plus 185 is 360. At that point, you could subtract 185, divide by 7, and you'll have your final answer on that one. I hope that helps you get started on two of those more challenging problems. And if you have any other questions, please